So some of you might think, MicroPython, what is this? Super tiny snake? Or maybe something to do with Monty Python or so. The EEE spectrum realized this ranking of the most used programming languages in 2018, and it's very interesting. Python is on the top, and it has a 100% coverage rank. So it's in the web, it's on your desktop computer, and it's now already also used on microcontrollers. And what I find quite interesting is that assembly entered into top 10 this year, which means probably because of the Internet of Things that are programmed with assembly. So MicroPython is a fully re-implementation of Python, and it seems to be lean and efficient to run on a microcontroller, because you couldn't be just using Python as you know it from your desktop computer. It needs to be, so it was rewritten from scratch to fit on the microcontroller. It has a virtual machine and a runtime system with garbage collection and everything you need to make it really efficient. There's bytecode or native machine code you can use with MicroPython, and there's also support for inline assembler. So when you have a project where you like to use Python because you want to get it up easy, but you need to make it more efficient in some of your tiny bits, there's also inline assembler supported. The compilation happens on the chip, so it's not compiled. Your program you write is not compiled on your desktop machine. It's compiled on the hardware you use. So as later as I have this fantastic camera over here, I will show you some demos how you easily can use MicroPython. How did this start? How did someone think of having a high-level, really high-level scripting language to run directly on a microcontroller? About 5 years ago, Damien George, at the time working at Cambridge University, thought, this would be fantastic to control my little robots with Python, because it's easy and I don't need to interact with all the low-level stuff. So he had the idea, let's run a Kickstarter, because at that time everybody was doing it, and I would really like to see how it is to do a Kickstarter as well. So, and he wanted to think maybe other people will be interested in having, and he would like to have an open source community around it to support the project. Because as we think open source is very important, because I profit from it every day, and we want to give something back. So this means MicroPython is open source. Everybody is welcome to contribute, and it's open to everybody. So this was about 5 years ago, and today, up till today, a lot has happened. When you look at our GitHub page, there are more than 7,000 stars and more than 200 contributors. Very interesting is that the contributors come out of different areas. So there are makers, but there are also people that work as embedded developers in the industry, because they saw the benefit of having a high-level language which you can start up, making it run up easy, and focus on the bottlenecks of your actual project. And there are also more than 2,000 forks, which means a lot of people are working on it. Some of you might have known the BBC Microbit. That's also one project in the UK. They were given about 1 million of these little PCB modules to the children in the UK to get them up and running quite early in the education process. So Python is taught in school in the UK. And this also, so there are other languages supported as well, but MicroPython is also on it. Then there are a lot of different development boards. For example, Adafruit has its own MicroPython board that's called CircuitPython. So if you want to try MicroPython, you have a wide range of development boards. And there is, of course, the official MicroPython board, the PyBoard, which I'm going to show you today. Because there's always an advantage on having your own hardware. Because you all know the saying, if you're serious about your software, you should do your own hardware. Then last year, there was the first MicroPython O'Reilly book from Nicholas Tolloway, which is also quite big. There are a few, actually, a few Maker books already out there, but this is a kind of milestone for us. And also, after 5 years, it's time to make a new board. And I have this one with me today. So what I'm going to try to do is, from the original Kickstarter, which was 5 years ago, this board is still supported. So if you have one of these software updates are still running and getting to be supported on the old board. But we were talking to people, what would you like to see? What do you missing at the actual on the market? And we try to listen and make a new board as well. So what's the benefit of a scripting language used instead of traditional C, for example, to program a microcontroller? It's learnability. It's easy. You can read it more easily. You have the ability to do rapid prototyping, which means your time to market is very quick. So even if all of you are just doing this for fun and are makers, if you see, oh, this is a really, really cool project I did, maybe I can do a product out of this. And some people might be interested. So I've heard about these stories. Oh, this all started as a hobby, but now I'm selling a couple of thousand units per year. So I started as a maker, but now I'm a kind of already business thing. It's also very easy to extend it by a user. So if you have something already up and running and you want a specific module implemented, you just get out, like it's open source, you can just pick it up and move it into your own way. So this is all very positive talk. But when I go out to people and tell them what I do, especially when I talk to embedded programmers that work quite near on the hardware, they say, oh my God, why would I do that? Python is super slow and I can't really use this on a microcontroller. This will kill all my benefit. Why I'm actually using a microcontroller for this project. So, and also, well, we are very used to C and we're very good. And so this is kind of turning a little bit around, open the minds of some people that work in this area. So they say they are interpreted, so they are slow. They use a lot of resources, Python. So this can't be energy efficient or efficient in any way at all. But I say, well, MicroPython is fast if you look at the development time. Just think about it. When you get a new microcontroller out there are thousands of sites of data sheets, and you need to get anything out of it and wrapping. Sometimes you have working examples from the manufacturers, but you still, well, that's when I did my final thesis in electrical engineering. It kept me up a long time to make it up and then make it efficient and make it really, for example, a really ultra low power as they described in the data sheet working. So if you have functions that already give you the access, you can really focus on the bottleneck of your project and don't waste your time in just making it get up and running. So as this is in the maker track, I thought there are a lot of projects out there. So for example, Damien George, which was the initial idea to do the PyBoard for the first Kickstarter, he wanted to do a quadrocopter. And if you want to learn more about this, there will be a QR code later on. And or for example, you can do this weather station, which are run by MicroPython. So if you like to find out more, there are a lot of maker projects in our forum where you can see, and they are described on GitHub, so you can build up on them if you're interested to use this. So that's the maker side. A lot of people picked up. But I am also involved in industrial projects that use MicroPython for the core architecture. And when I talk to some of the developers over there, they ask me, or they tell me, or I ask them, why did you choose MicroPython? Because it's just around for maybe 5 years. There is no really long time. So there is no saying, yes, we have tested this 10 times in the field and it's up and running and it's running 24/7 or anything. There's nothing there. So it's quite a brave step to do it like this. But one of the developers said, yes, we were looking for a replacement for our embedded Linux system, because an embedded Linux system for this tiny device we are using is just too bloated. We don't need it that much. So the first prototype-ish was with shell scripts, and they replaced it with MicroPython. And after 2 times, not with this initial project, they got on with it because they really like to use MicroPython. They are now in low-power systems that consume less than 500 nanoamps with active programming on the microcontroller, which is quite impressive when you think about the real-time image processing they're using it in. So the interesting part is you have it in your development phase, but you can also run it on the final product to, for example, get some updates on there. And I hope this gets more clear when I'm trying to do a demo later. So, and what they said is, yes, of course, you cannot use MicroPython for everything because you might need some assembler code there and there bits, and then you just integrate it. And you're really, really fast to show a first prototype to a customer or to your supervisor that you get something up and running with new hardware. And also MicroPython is quite famous for used in school calculators. So about, I think, 2 years ago, the first calculator picked MicroPython up, which is NumWorks. It's a startup. And they have these graphical calculators that use MicroPython on them. And just recently, we heard about that Casio is also putting it into their microcontrollers. So this is the old cute little snake logo from the original Kickstarter, which you put on. So that's the good thing about the open source. They are allowed to do it, so they pick it up and move it into their direction. So I hope a few of you got excited about it and think, oh, that's cool, I would try this out, but I don't have a board. Don't worry, you can go on our homepage, and there is an emulator where you have this little PyBoard, and you can run a few demo scripts and can see it if you like it and put it up. So no need to buy hardware, just we have this emulator as well. More companies that are using MicroPython is obviously Damien George, who created MicroPython and also offers development board around so he designs hardware, specific hardware or specific modules in MicroPython. And what he says is, so my background is theoretical physics. I'm not a typical engineer who looks like more just to getting a problem done or solved. He's more research-oriented, and he believes, and I believe that too, that's the thing why MicroPython got so successful, to not just find a solution for a specific problem, otherwise to go on and make it more usable for everybody. And there are other companies, so this is just, I picked just one, more people are using it. Like these consultants that do development for customers. And Travis Travelstead, for example, he come across MicroPython because it's always hard to find components and tools that are, on the one side, they're easy to use, but need to be on a professional applications level. And this draw him to MicroPython. So that's what he told me. He can set up adapter boards and stuff, as you can see here. These chips he's using here is the same as the PyBoard, which is the original one. Just plug it into an adapter board and get stuff up and running easily. So just as a little bit of an example. So when we look at this, it's the amazing software, all this implementation, like all this rewrite of Python to make it really running like clockwork on the hardware. So that's one side. But the other side is MicroPython, or George Robotics, the company behind it, does their own hardware as well. So if we could switch to the camera for a second, I can show you. Yes. So you can see here, this one is the original. So ever how small it is. This is the original PyBoard. This is a PyBoard Lite, actually, but the form factor is the same. And the new generation moved to this one, because we were thinking, what people told us were, yeah, well, we like these little modules. You probably have heard of the ESP32 or the ESP8266. They are small, tiny, easy to access and everything. But when you buy these modules, you still have to design a little PCB to program it for the first time. So that's what they were missing. So we designed in a micro USB connector to make this up and running easy. A Cortex M7 CPU for power, a Wi-Fi module with BLE, and on the other side a micro SD card, so you can still exchange your. So you have an internal file system, obviously, but if you want to really collect data locally, you might like to have an SD card as well, or storing all your programs. And here you see these bus connectors, which are officially designed on being plugged into other adapter boards, which you can design yourself. So that's the aim of MicroPython. There will be some, obviously, to get you up and started, but what we really want is that people easily can design their own products and having their heart of the products out of the box already up and running. Yes, okay, so I would go on with the demo now. Yeah. And show you a little bit of the code that's on the board. So I'm starting with the original Pi board. Yeah, very good. And here you can see this is also an adapter board. So, and here's a sensor board, which can be plugged in as well. So here we have a RGB LED, a temperature and humidity sensor, a light sensor, and a little buzzer for some sound, so you can see, is there actually something happening? Everything is better with a little buzzer, isn't it? Okay, so this one is plugged in now. And if I switch back, perfect. Yes, I like this. So this is the pipe flash, just comes out as it pops up like a USB stick or something. So when I go in there, I have my main Pi, which is empty now, I believe. Yeah, so you can put your code here. Just type code and save it to your board and run it. But obviously, I have something prepared because I want to show you how easy it is to run the little sensor tile I've shown you. So this is just a little driver written for this tile that I plugged in on the top. So you have the optical sensor, as you can see here, or the temperature and humidity. This is just to see this code is already on there. I don't have time to do all this now. So I'm going to show you how easy access. So here in the background, sorry. As you can see, MicroPython, PyBot Lite, type help for more. So we are already on this board. You can see, I showed you earlier before. If you type the help, it says a little bit about the control and everything. And I'm gonna import the program I just showed you earlier and run a little of the test script. So, as you can see, there's roughly 25.3 degrees, 32. This seems a little bit low. But I also want to show you a little. If we could now switch back to, so as you can see, it's RGB LED just counting the different colors up. And I'm going to do some measurements. And it's going to be shown in the interactive wrapper. So there's, what's the amazing thing about this, as I would say when I first came across this, is, oh my God, I just need nothing to install anything. I just need my Python code. And obviously I need to know how to interact with my sensors and everything. But I don't have to install an IDE. I can use one if I'm used to one, but I don't have to. So I'm going to just like lock this into a text file, and then I have this, and I can use these data easy, like from the plugging it in and using the data to make some of my plots or whatever I need them for. So this is still the original PyBoard. And the same sensors can be used with this one. Like this is the half size-ish. And the same code runs on this board. To do this like this, I can see something. Yeah. So and if I now go back to my code, and run exactly the same, import the same program that's also on the so what I try to show, we try to do this all very modular. So still all of the old hardware will be still supported with the new upcoming sensors and styles. I think most impressive what I said, that they managed to make these things very, very small, because I think that's the most important part. If you run the Internet of Things at some point, you have the things should be tiny and mostly running on very low power. Oh. Sorry. That's the wrong button. The right button. And as you can see, there's a microcontroller on it, and the Wi-Fi module is separate. So why is that? To make the board more more expensive, obviously? No. To have the real-time availability of the microcontroller, so that you can really focus on the task. And most of the time, you might just need the Wi-Fi to send the data off, and don't have to really have it on all the time or something, or need to wake it up through Bluetooth or whatever. So when you can see here, there's just a comparison to the old PyBoard 1.1 and the PyBoard D, which is the new one. It's got faster, obviously, because the microcontrollers evolved. And it's from 34 milliamps to a deep sleep to 10 microamps with the real-time clock still enabled, so which means it can be woken up. So this is a whole new area on what we really like to see the Internet of Things running on. When you think about it, that you don't want to go around and exchange batteries every time. Or I think is 20 billion by the time of 2020 that will be out and running and collecting data and sending them back. So the power problem is really a thing that needs to be focused on. So this is all very positive, isn't it? This can't be all so good about MicroPython, can it? So what MicroPython cannot do, or is not, as it always, you need to see your problem that you want to solve, and then you need to look at what is available, or what could I use with it. So really, really small MCUs that don't have enough RAM to put the MicroPython source code on it, they still will use traditional C, because they are just not made for having these kind of operating system. So MicroPython is an operating system like an RTOS, you might know. It's re-implemented on the bare metal, but still kind of acts like an operating system. As you can see, how easy it was for me to just switch on and access these different pins. And also, for example, for larger projects, especially when you work with a lot of people, you might like to have an embedded Linux system on your device where you can control everything. But I know of a company that has an embedded Linux system on a product, but still uses MicroPython for the special tasks, which is very interesting because they already use this hardware on their extension board, and they are running in really reliable, like in industries where you need to be have the reliable data. So, as I know, this is the maker track, but when you think about it, making a product or really designing something for that's being used in a couple of thousand times, so MicroPython can help you with the product development in productivity, traceability, because the code and the different firmware releases are very it's very well maintained and in the open, so people can work together, fix problems, and the community can profit from that. Makes the testability easier. As I've shown you before, there are more than 200 different developers involved, and they come all from different areas. And sometimes you get these ideas from people you have not even thought about because that's their main thing they do. And so that's really fantastic to see how everybody makes each other like better. Then the license of MicroPython is the MIT license, which is very flexible. So you can use MicroPython, but you don't have to have everything open source. You can build on it and close up the thing that makes your product, that generates the profit for your company, for example. And yeah, as said, as the support in general, the Python community is quite open and supportive. So is the MicroPython as well. The disadvantages, again, well, you might have increased hardware resources if you can use a smaller microcontroller, which is obviously cheaper, but it's too small to fit MicroPython on it, and you cannot use it. So this needs to be like, you always have to look at the time you need to pay for your developer that does the actual hard and software development compared to the price of the hardware you're using in your product. And sometimes it is in this area still, people don't use Python. They still use C or even assembler or the low-level languages for designing and programming with microcontrollers. Yes, I hope you enjoyed the talk, and I would be happy if you have some questions for me.